Okay, this is chapter 2.5. This is video number 4. So this is the back page, factoring in specific polynomials. I wrote this all out. You can just read through it. I'm not going to go through it all, but just completing factoring over rational numbers. That means everything except for I, the imaginary number, or a irrational number, radical. So we would only be able to factor it down to that point. And then the next one would be completely factoring over real numbers, in which case it'd be everything except for I, our imaginary number. So if we were factoring over real numbers, we could get it down to this far. We couldn't go any further, specifically with this x squared plus 6, because to factor that, we'd have to bring an imaginary number in. So when we talk about under real numbers, we can have the radical in there, we just can't have the imaginary number. And then factoring over complex numbers means we can basically do everything in there. We bring in, our radicals, our irrational numbers. We bring in our imaginary numbers. And the other thing is, given zeros and a point on a function, okay, we can use that to solve for vertical stretch or shrink. In other words, we're going to solve for the a in our equation. So we'll take a minute. We'll look at what that means. With this problem, given the zeros, multiplicity, and a point on the function, determine the equation of the polynomial. So here we have, notice it's a 4th degree polynomial, but we have 1, 2, 3. Because 3 minus I is one of the zeros, we know its conjugate 3 plus I is also a 0. So let's write this out. F of x equals a. Since it gives us this point, we know that we're going to find this a value. We're going to see what stretch or shrink it might have. And then I'm going to go, let's see, x plus 2. That takes care of my negative 2. X minus 1. That takes care of that 1. All right. And I'm going to have x minus 3 minus I. That's that right there. And I'm going to have x minus 3 plus I, and that's my 4th degree there. All right, now I want to start multiplying all of this together. F of x equals a, this is going to be x squared plus x minus 2. All right, that's right there. Over here, remember from a previous video, I'm going to redo the parentheses. I'm going to redo the grouping. So this is actually going to be x minus 3 minus I, but I'm going to group it like this. And x minus 3 plus I. And again, I'm regrouping this. That way when I multiply, I'm going to multiply. This is my a's, so my a squared, x minus 3 squared. Okay, minus my b's, and this was my b, so my b squared. So minus I squared. And this part here I'm going to leave as it is. And this a stays here. This is f of x equals. So f of x equals a. Let's just start simplifying a bit. X squared plus x minus 2. Still not doing much with that. Going to expand this out. X squared minus 6x plus 9. And then this is going to be plus 1, because it's I squared equals negative 1, negative 1, negative, negative 1 plus 1. All right. F of x equals a, x squared plus x minus 2, x squared minus 6x plus 10. At this point, this is a good time to find a. Okay, meaning that I'm going to use these values up here, this f of 2 equals 4, to find out what my a value is. I'm doing it now just because the math is easy. The way I have these two polynomials here, these factors. So I'm going to come in here, and this is going to be 4 equals a, And this is everywhere there's an x, I'm going to put 2 in there. So 2 squared plus 2 minus 2. 2 squared minus 6. 2 plus 10. Okay, 4 equals a. Let's see, this is going to be 4 times 2. So I have 4 equals 8a. So a equals 1/2. Whew. All right, I'm going to have to kind of go into my other page here. It's okay. So back to my work at hand. F of x equals 1/2. And I'm coming back to this equation here. X squared plus x minus 2. X squared minus 6x plus 10. And I've got to multiply all that together. I wish I knew how to edit this so that I didn't have to do all of this out, but actually have it right here. Good. X4 to the 4th minus 5x squared plus 2x. Oh, this is, I'm sorry, this is cubed. Negative 2, positive 2x squared plus 2x squared plus 22x minus 20. Whew. So that's a lot there. But I've written, given the zeros, the equation of the polynomial with, the key thing is I have this